everyone. Today we will solve this today's LeetCode problem, which is valid parenthesis string. Let's see what is the problem. So here it is given a string S, which contains only three types of characters: opening, closing, and star pattern, and return true if S is valid. And we have defined some rules here that every left parenthesis should have a right parenthesis, every right parenthesis should have the left parenthesis, and this left parenthesis must go corresponding to right parenthesis, and this is star. So here is a fact that it will be the same problem as valid parenthesis string, but here this star is given, which can be a right parenthesis or left parenthesis, or this can be an string, empty string. So this is something like wildcard matching, right? So this is valid parenthesis. So what we do in valid parenthesis problems, that we simply take an open bracket, and when we counter an open bracket and we increment the count, and when we encounter a close bracket we decrement the count variable. But here that approach will not able to effectively approach due to greatly, because here it is a star and we don't know what this star can be. It can be the open, close, or empty string, right? So where we have any options in our question, we can think of dynamic problem approach here, right? So let's see what can if we do. Let's see this star, and this again, and this, right? So 1 2 3 4, 1 2 3 4, right? So this star can be an empty and closed and anything, right? So let's take a simple example here. This star can be anything. So how we do know? What we can do, just like we have solved valid parenthesis problem by taking a variable, counter variable, right? Count variable. That what we do, we simply, when we see open bracket, we increment the count, right? When we see open bracket, we increment the count, and when we see close bracket, we decrement the count. We use just this counter variable at every index, right? And we will see, and whenever I get an start variable, I will first assume that this is an open bracket, then we increment the count. Then I can assume that it's a close bracket, then I can decrement the count, and I also assume that this will be an empty string, that neither open nor close, then I will keep the count same. So what will be the approach for this? So suppose this star is at every place in whole, so that will be the 3 to the power n is the length of this string, right? N is the length of the string. So this will be 3 to the power n, which is so if I see the length is given 100, which is equal to 3 to the power 100, which is very high time of complexity. So we can use, this is a recursion problem, so we can use a dynamic approach, that we will make what we are doing, we are iterating in this iteration. So we will take an approach, and we are also, the variables are changing this count, and so that will be the n and count, and that this will store the answer number of counts at every index, number of parentheses at any index, that whether at current index, what it denotes, it denotes that at denotes at which index is valid, till that index denotes that till this index, the parenthesis is valid or not, right? Simply. So this is the approach. Let's first see the memoization approach. So this will be s.size. We will return this solve function. This will be 0 and this s. And also I need to maintain a count variable for incrementing purpose. So let's make this solve function, this and I, this and cnt and this should be the string, right? So what we'll see, if si is equals to open variable, I will go into this. I need to take an answer variable which is equals to 0, and I will also take odd answer in this, and this will be I will increment this and also increment the count variable s. If I get close bracket, I will decrement the count variable, I will increment this index and I will decrement the count variable, and this will be s. And if I get the star, there can be three possibilities, that this will be solve I plus 1 cnt plus 1. It can be an open bracket, otherwise it can be a close bracket, or it is simply an empty string. So we will simply increment this thing, right? So this all can be a possibility, and we will simply return answer. So here I need to handle the base case. If I is equals to the length of this string, this will be return this will be 1, because we have completed this. Otherwise, yeah, we will simply return this. Otherwise, we will see that whether this cnt is less than 0. If cnt is less than 0, we will return 0, right? And also need to see that this cnt should equals to 0, not less than 0. If this is equals, then it should be return 1, otherwise return 0. I think this will work. Okay, still should be return cnt 0, not. Why need to check the cnt variable? Because if it is not equals to 0, it means we don't have equal number of left and right parentheses, right? So this will be return equals to 0. This is the base condition which we can follow. So let's run, see whether this can pass. Yeah, it's passed, but we need to memorize it further. So this is only recursion approach, we need to memorize it. So let's take a dp, and what will be the count variable? Count variable can be at max n, at most should be only 0, but it can be at most 1. So n, so that will be n comma minus 1, and we will pass this here, and this will be dp here. This should be dp I cnt equals to answer. And before going this, I will check before that whether it is -1 or not. If it is not, then I will simply return dp I cnt. Otherwise, I will simply return it. So let's see. Okay, I need to pass dp everywhere. Dp, or okay, no problem. I can also make this as a global variable, but yeah, no problem. So let's in this dp. It's coming a runtime error. dp I cnt. Is it possible that cnt, I think it's an overflow due to this. Let's debug this. What is the cnt here? I think CNT is okay. This is -1. CNT is less than 0. So yeah, I have removed that condition, right? I don't need to remove this, still will return 0. That's the base condition also here. Let's run. Yeah, let's submit it.